Okay, well, welcome everyone to this meeting of the Virtual IMS User Group. Thank you for joining us and thank you for waiting. I'm Trevor Eddles. I'm CEO of iTechEd Limited. We're a mainframe consultancy, analysis and technical authoring organisation, and we're responsible for the content on the Virtual IMS website, which, as you can see, is at itech-ed.com/virtual IMS. So let's quickly run through the agenda for this meeting. As usual, most of it will be taken up with a presentation, and today our guest presenter is Loc Tran. He's lead software developer at BMC Software, and his talk is entitled How to Use IMS Log Records to Investigate Transaction Response Time. A copy of his slides should be on our website later on today, certainly by tomorrow. And if you've missed any of our previous meetings, you can download copies of those presentations from our website as well. The link to everything is on the resources page. So following Loc's presentation and any questions you have for him, we'll move on to the latest IMS news and latest IMS related articles. Then we've got coming soon, where I'll tell you what's our next couple of speakers, or who our next couple of speakers are going to be. Anyway, oh, excuse me. As I just said, today's presentation is from Loc Tran. Loc has been working with IMS since 1985. He was systems programmer at AT&T and Geico. In 1996, he developed TMON for DBCTL and IMS for landmark systems. He joined BMC Software as a lead product developer in the main view for IMS Group in 2002, and he's been there till the present. He's enjoyed working with IMS, and he's spent almost his entire working life with it. He always tries to create features in products he develops that IMS users need to do their job, to make it easier and better. So, Loc, what I'd like to do is thank you very much for being with us today, and I'm going to pass control of the meeting over to you. Before I do that, though, can I just say, if anyone's got any questions for Loc, if you can just pop them into the chat and I'll read them out to him. So let's change your role to presenter. Right, you should be able to share your screen now, Loc.
Okay. Right. If I want to share everything. Okay. Do you guys see me?
Yes. Yeah, we can see that.
Okay. All right. All right. So first of all, sorry about the delay. I was having problem with WebEx. It's been a while that I have used it, so sorry about that. So that's sorry about the delay. Okay. So the topic today is how to use IMS log records to investigate transaction response time. As you already know, IMS log records are very complex, and it's very hard to use the log records to tie to a transaction. And so that's why we have the session today to discuss about this. First of all, the agenda is that how we gonna IMS write log records and why does it do that? Okay, and then we talk about the IMS log record components, and then we talk about the IMS DFS ERA 10 program that where you can extract or copy log records for your use. And then we discuss about the technique of how to tie log records to a transaction. And we discuss about the full function situation, and then we talk about the more complicated message switch set of log records, and then we talk about fast paths, and then follow up by a demo. Hopefully, I have enough time to give you a good demo on on the lock records. Okay. All right. Why does IMS write lock records? As you probably know, the number one reason is for database recovery. The undo, redo, database change, the lock record 50. And then we use, IMS use lock record, the 40 and 40 type of lock record to do forward recovery from the system checkpoint. And then the database data communication recovery to restore terminal status. As you can see that lock record has information about the VTCB control blocks, the CNT, CLB, CTB, all of that will be restored to the way it was when IMS come down abnormally. And then restore the queues and many other situations. And then it also lock record, IMS write lock record to show the statistics information for IMS, for example, the 4,500 lock records. Okay, so how does IMS write lock record? The module, the program that write IMS lock record has to run under an iTask. Okay, it's part of IMS, whether it's a control region, whether it's in DLI SAS, or whether it's in dependent region. You can write lock record, but you have to run it as an iTask. So basically, you issue a macro like this, ILock, and then write function. You provide the DECB, the record address, and then you have to provide the SCD address. Okay, and then I just cut and paste the extension of the macro. That this is what it does. All right, assembly, just only few instructions, and then it get the address of the IMS logical logger. Okay, it get it from the SCD. So if you go into the SCD at this label, you will see the address of the logical logger, and then you branch to it. Okay, so what the other components, like I mentioned to you, the module is DFFLSG0, which is the guide that branched from the SCD to it. If you want to know how IMS handle a lock record from the point that it receive, okay, and then it write to the watts, all right, and how it waits for that, and how it tabulate the response time, the statistics for the function. You can look in here, all right, in this module. And then, of course, the lock record will be copied to the buffer, the lock buffer. Then lock buffer, when it's full, it's write to the OLS, right? And then when the OLS is full, it archive with DBRC trigger the archive job to archive the OLS to the SLDS, right? And then the SLDS recorded in the recon, DBRC record that. So that is the component of handling IMS lock record. The reason that I mentioned that here is because in the recon, when you want to look at the lock record for a particular time, you have to go and inquire the recon to find the SLDS, right? So from the SLDS, you said, okay, now I have the SLDS cover this time to find a particular transaction, or the transaction abandoned, or it runs forever, whatever. Then you use the DFS ERA 10 to extract the lock record that you want. Okay, so when you have a bunch of lock records that you or you don't know which record to read, I recommend you to use the ILockRec Micro. You can find it from the MacLib, IMS MacLib, and this is where you get into that, and then you will see that here, the if statement here, like L01, L02, L04. So if you want to look at lock record 6, Okay, system restart, let's say. Then you do a find L06, and then you repeat. It will bring you there. For example, if you want to see L01, which is the IMS transaction input record, then you come here and then you can see right here. Oh, sorry. You can see right here that that's the name of the macro, right? The DSEC, the queue lock message input, I guess, right? So from there, you can go into the MATLAB and you can look at this and you will see the mapping, the DSEC of the lock record that you want. Okay. So we're talking about the program IMS DFS ERA 10 program, right? What does it do? It allows you to choose from the SLDS as an input to extract the record type, the value, and then you can specify the or you look at the lock record and then you have a value in the lock record that you want to search for. You can print the lock record or you can copy the lock record. When you print, you can specify the exit, like DFS ERA 30, to print it in different time format, the way you want it. Okay, you can look at the manual to see how you control that. So and then, or you can say that control, you skip the first, like in this case, 305,000 record, and then you stop after 306,000 record, and then you select the record type that you want at the offset. Okay, so in here, I give you an example of the control card that you want to print or or copy from the SLDS. Lock record 137 at offset 5, and 831. These are the ones that affect your transaction response time. Okay, so you can use that as an input to your DFS ERA 10, and then maybe you should use the before and after, limit the number of lock records so that you can see the IMS lock record that during that time. Okay, so in the demo, I will show you very detailed of how you do that. Okay, so how do we tie IMS lock records to a transaction? Prior to data sharing, IMS only use, a single IMS, a local IMS system. We use the DRN identification in the lock record to tie the lock record all together to represent a transaction. It's very complex. Okay, DRN stands for disk relative record number. It's pretty complex to do that task. But then when IMS introduced data sharing, then it introduced the UOW, right, unit of work. So the new method is to tie them by the unit of work. So we call them by a logical unit of work. So because in the UOW, you can message switch to another transaction, which has another UOW. You see? So if you want to find response time from A to Z, you have to tie the UOW. And you probably already know the UOW has 34 bytes in it. And that's what you will see in the lock record. The first 8 bytes is your IMS ID of your local IMS ID, and followed by the 8 bytes of the store clock. It's unique. It has to be unique. And then the next 16 bytes followed by the we call the processing UOW, which is the IMS ID that in a way process the transaction. And then it followed by the store clock of that. All right. If you run locally, then your First 16 byte is the same as your second 16 bytes for the same unit of work. But then if you message switch to another transaction, then you will have a different processing UW, which is the next 16 bytes. And then the last 2 bytes is the AQ of the clock, of the offset to the clock. Okay, so in some lock record setup that you use IMS ID plus the store clock, but sometimes some lock record use IMS ID plus recovery token. It doesn't use the store clock. For example, the 56 lock record. Okay, I will show you when I do the demo that it uses a recovery token, and also in FastPass lock record, it used the recovery token. Right? Okay.
Question
Yes.
for you from Karen Tischer. Earlier on, you were talking about skipping forward. She's asking, how do you know how many to skip and where to stop? And she said it is a timestamp control.
Right. Okay, that's good. That's a very good question, because you have an SLDS, right? From DBRC, it tells you that, okay, this SLDS, let's say that you have a problem, a lock record, a transaction problem at 8:10. You're going to have to ask DBRC in the recon, give me an SLDS that cover at 8:10. So the SLDS just happened to be starting from 8:05 to 8:15. Right? So it covers that the lock record that you want. So you get that SLDS from DBRC, and then you're gonna browse it. I don't know any other method, or you can use the time from ERA10. That I said I want to look at lock record from this time to this time, or you can look at the sequence, which I will show you in the demo. Look at the lock record sequence at the end of each lock record to see the time. And then you said, okay, I want to look at this sequence to this sequence. All right. And then you will print or copy it to another data set and then print it later for you to look at. I will show you that, but that's a very good question.
Yeah, that's brilliant. Thank you. I think she's just commented that she understands what you're saying now.
Okay. Yeah. So we will show you. Okay. So now I just want to go quickly with these lock record. This is a full function, a full set of lock record. You can use this and to analyze the response time of your transaction. So let's say we found this transaction. You based on the ERA10, the input that you want to pick out of these lock records. All right. So let's go over that quickly so that everyone understand the O1. So let's say that you type a transaction in when you log on to a terminal, an IMS terminal. You type a transaction name. In this case, IVTNO, for example, and then you IMS will you log on to VTime. VTime get it to the VTime buff. VTime said, okay, I have a message. I have an input for you, an IMS, and IMS set up a bunch of receive any buffer. Okay, the Recani, if you know IMS DC, the Recani has a wake up call from VTime said, hey, there's some work for you to do. IMSTM look at that and because the Recani buffer is a privileged iTask. He got that. He said, okay, let's look at it. Okay, IVTNO space and the input for the transaction. And he looked at that. He said, okay, he looked at the SMB table and he said, okay, this is a transaction. So I know this is for a transaction. Okay, it's not for another CNT destination, another terminal when it's trying to communicate with another terminal. So this is a transaction. So the FSICIO 0 write out the lock record. It does an ILock 01. So this is the input of a message at the beginning of a life of a transaction. Immediately after that, because this is a queue management system, right? So it has to enqueue the message to the message queue pool. It write out lock record 35, right? It always immediately when you see 01, you will have a 35 because because it's nothing usually in between of that. When 35 write out to the message enqueue, and then it signal the IMS scheduler. I said, hey, I have a message for you to look at. Scheduler coming in and look at that message and said, okay, based on an algorithm from the scheduler, he finds out that I found a region to run your program. Okay, so when that happens, it write out lock record 08. That's a program start, beginning of the life of the program. All right. Now, and then IMS said, okay, the program start, I'm gonna need to write a 5607. This is the one that I told you, the EOW, the second part of the EOW is the IMS ID and the sequence, the lock recovery sequence number. Okay, that's how you to tie. The reason I tell you this is how for you to tie with the rest of the transaction. And then the program start, the region controller, DFS PCC20, give control to your program running as a PRB, and then he does initialization, whatever it needs to be done, COBOL, PLON, and then it goes to the initialize certain fields in your program, in your application, and then it does a get unique on IPCB. That's why lock record 31 comes out. Okay. Okay. Now, I want to stop here a little bit to tell you that for performance, for the performance reason, I want to explain this. Between 35 and 31, okay, just a little bit after 35 and 31, that is what we call schedule to first DLI call. Okay, this time is very important to the way that you do performance and you measure transaction response time. Okay, for example, if you between 35 and 31, if your program is not preloaded, IMS will have to do load for you. Okay, if your program is big, okay, and the block size is a little bit smaller than your program is 1 meg, it will take quite a bit of IOs to get it, right? And then if your program access DB2 plan, during this time, IMS will have to get initialized for your DB2, and if your DB2 is not there, because you're not reusing the thread, the MPR here, you have to create a 2 TCBs for DB2 access, all right, for your plan. So this time can be very long, all right? So the reason I mentioned that to you is that for you to do performance tuning, it means that when you do Wi-Fi, you bypass that process. Because why? Because you'll get unique on IPCB, the 31 that you see there, all right? The 31 there will, when it's done, the transaction is done, it does get unique on IPCB under a Wi-Fi environment. You stay there, you get a pseudo wait in the sub-Q 6. So you're not terminating the process. So you bypass everything from the 35 to the 31. Okay, so the time, if you see the time difference over here, it will tell you how long you have to wait to get your program initialized and ready to process the first message. All right. All right. Now, so this program does a database update. So you got a raw lock record 50/50 undo redo. All right. Which is not very important to us. Well, you can see that how long it takes. It takes pretty long, 22 milliseconds to do that database update. All right. So the application's got everything it needs. It write out a 03, an output message. Okay. An 03 has in here with destination, CNT destination, it will write out a message back to the terminal. Say, hey, this is a result of what you're asking me to do. And then, of course, when you write out a message, you have to enqueue the message, right? So 35 come out again, and then it's done. So it does a message transfer. It's ready for sync point. Okay, it's ready for sync point. That's why it got 33, 37, and then the 33 come out. The 3301 message free is to delete the message 01. the 01 NQ there. I said, I'm done with this message. I'm done with him. So, so so in this situation that you can see, the 31 here, the message get here, is actually not the, because it's going through sync point. That's why you got a 37 there. And then this 31 is not the 31 from the application. This 31 is from IMSTM, Transaction Manager. Transaction Manager said, okay, I have an 03 that I NQ on the 35. Output message. I need to deliver this message to the terminal. So that's why this 31 is for that, not for the next message, a transaction message, okay? So 5612 come out for two-phase commit recovery, and to do that, and then 5607 for sync point, and then another 5612 to complete this processing. And then in this case, you could, if you ask for a 56FA, okay, this is IMS record, and I don't have it in my system because I have, BMC has write out our own log record, the FA for a transaction record, and an F9 for a program record, all right? So we write those two, so we don't need that 56FA, but I will tell you how to get that, all right? And then that means that the transaction ended and the program ended. And then you have an 07 is a termination of the program. In a production environment, you do not want to see this very often, right? Because when you do a program end, it means that the next program on this region will have to go through an 08 again, which is what I told you about. So you're trying to use a PWiFi or Wi-Fi to tune, or you use a proclim to tune your IMS, so that this thing doesn't happen often. Because when you do this, you only process one scheduling, one transaction executed, which is not the way that you want it. All right. So this 36, the next after the 07, the 36 comes out is message DQ. This message DQ is to DQ the 03, the output message. All right. So it means, what it means is that the message is delivered to the terminal. Okay. So end-to-end response time for your transaction is the 01 and the 36. Okay, or the 33. You can use either one. In some situation, you cannot use 36 because some transaction does not deal with a queue. You have to use a 33. For example, APPC, okay, APPC CPIC transaction does not deal with a queue. So you don't have that. So in order for you to report, to look, to find the response time of your APPC CPIC transaction, you have to use a 33, the message tree, okay? So that's why I explained to you a little bit detail here so that you can see. All right, now.
Okay, look, I have a couple of questions for you.
Okay.
Can I do them now? The first
I'm
one
sorry
is,
now. Okay.
Sorry, the first question is Wi-Fi nice, but what about VLF/LLA instead?
Yes. Yeah, you can use that to load the program. VLF, you mean you want to put the program there so that the ZOS can give you the module faster. Is that what you want to do?
I'm not sure. I can only say what's in the question, but that sounds sensible. Secondly, right. Where does MFS edit occur?
Mm-hmm.
She's saying she thought it between 01 and 35.
No, MFS was done prior to this. It's not part of this.
All right.
Right? MFS, because the way that VTime Communication Analyzer, if you want to know a little bit more detail of how does it do, you look at the module called DFS ICIO0. That's called VTime Communication Analyzer. So when MFS coming in, let's say you do a /4 IVTNO, right? So that's MFS. When you hit enter, you put the name, whatever the name and address, whatever in that for that transaction. You hit enter. When it comes in, VTime communication analyzer look at that. Oh, this is the MFS. So he called an MFS module to to parse out the data, right? To parse out all the data depends on the terminal type. It's a 3270. If it's 3278, it's in this format. So it's called device dependent module, called DDM. So to handle all that, the format. So when the format was done and it stripped all of that, you will see. I will show you exactly in my demo, okay, to see the data. So when O1 is written, it only it strip out everything except IVTNO space space space. Last name is Tran, first name is Loc, extension, blah 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 blah. So that's how you see. It's neat to see the demo to dump the record for you will understand. Okay, so MFS was done prior to this. It's not part of anything, right? Right. So after it strip out all that, it write the O1 lock record. It's a very good question. Very good question.
Yeah, okay. Thank you. I've got another, if this is a question or a comment, is saying, gosh, with the,
Yes.
I'm not sure what the letters are. Sorry, it says WFI/PWFI, even with VLF, I thing, there are destruction of application TCP in the MPRs. That is also why preload is used, so the use count in the CDE is never 0.
Mm-hmm.
Right.
Mm-hmm. Yeah.
So
Yeah.
that's a comment. Yeah. Thank you.
Right. Right. Yeah. So that's why we want to preload the program if we can. Yeah. Yeah. So also you can, if you run COBOL, you can preload a lot of service module, COBOL service module. A way to do that is to run GTF against one of your region that you are interested in. And then you look at the IO to which program is loading. All right. And then, okay, the COBOL, IEB, I forgot. I left the field for so long, 30, 40 years ago as a system programmer. I look at that and I say, okay, this COBOL program is called very often. So let's preload this in VLF or what we use, LLA, things like that. So to make the read faster, to load the program in faster, or something like that, or preload the actual module. Sometimes that you cannot preload the module because the module is so big, right? For example, the module can be a meg worth. I work for AT&T, and we used to have a meg worth of application, and you cannot preload a lot of them. At that time, real storage was like very scarce and very, very, very expensive to do. So you have to really monitor the size of it to achieve speed, right? So if you use DB2, I recommend to use Wi-Fi. If a program is highly used, it should run and schedule under a Wi-Fi to reduce the scheduling time, right? Okay, so let's move on to let's tell you how to produce the 56FA record. The reason the 56FA is written between the two sync point. I'm going back here. Between the two sync point, right here. Right, and then sync point. So it write the 56FA to record the statistics of that transaction, right? If you don't have that, and the F9 here, which is the program, one program can execute multiple transactions, right? So if you run, it's a P-Wi-Fi, for example, in one schedule execute 10 transactions, and the data are piled up and accumulated on the F9, on the O7, in the case of O7, and then you don't have data for a particular transaction. So that's why you want to produce this 56FA. That's for a particular transaction, So in order for you to do that, I don't have it in my system because I believe the FA has a lot more detailed information than the 56FA. So we don't collect the 56FA. So it mapped by the DSEC, DFS, ETP, CP. You can put that in here, say, I want to collect the 56 FA. So you, in DFS, DF, XX, say transstat equal yes in the diagnostics statistics section for all transactions. Or you can do you can do an update on the transdesk description with a transstat field yes, okay, for a particular transaction, transaction name, okay. All right. So I want to move on because we get into a very difficult situation. Here's a message switch. So I don't need to repeat about 01. You already know, you're an expert in that now. 01, 35, 08, 56, everything the same. You can see here is a 31 message get, right? Get unique on IPCB from the program, your application. And then it does whatever it got in, and then what it does is it output a message, okay? So, but then in here, in a 03, you have two type of 03. Wow, just make it simple here for this situation. If you have an 0381, okay, subtype 81, it's a message switch. You're switching your insert to an alternate IOPCB. Said I want another kick another transaction, right? And then the message NQ, as you can see here, like just like you saw before it, and then the preparation for the end of this of this original message, right? And then 33 to delete 33 here to delete that 01. Okay, and going through a recovery, the two-phase commit, and then this 31 is probably we're going to have to look at the dump of the record to see, all right, based on the EOW or the DRN, and then to match with that 03. So that 31 probably come from that 03. So does it get unique on IPCB? See, so it's done. So that's why you can see the FA here is written, right? But you don't see an 07 yet because during this test environment to capture this screen, I use only 1 MPR. So that transaction will run in 1 MPR only for you to have this sequence, all right? So that's 03 is another output message, all right? And I did 2 switch. So this is also NQ, the message with an 81 SMB destination, okay? And then I go through the same process, and then the next message is that the third transaction does get unique on IPCB, okay? And then an FA is written for the second message, okay? FA, which is FA is at the end of a transaction here. And then I'm going to go the next. I don't have enough space, so that's why. Okay, and then you do get unique on IPCB, and then the program issue an 03. And this 03 is also considered as an output message, but an 82 subtype is a CNT destination. It's I have the result. I'm sending back to the terminal. You will see that in when I do a demo. And then at NQ the message, right? And then that third transaction ends. That's the FA came out. And then the program ends. That's why we have an F9 equivalent to an 07, right? So program ends. And then this 31 is, like I mentioned to you, is a TM, get unique on LPCB to get that message that is outputting, okay? And then deliver the message. So that is your end-to-end response time for that first transaction. That's 36 here. So you should be able to tie this 36 to the original 01. That's your complete picture of that transaction. But sometimes you want to see the transaction in the middle. So you have to, which means that you're going to have to find between this 31, oh, sorry, this 31 and this FA, and this sync point right here, which is 56 FA here. Okay, so that is a small 1 EOW, right? The whole thing here we call the logical unit of work because they all have the first 16 bytes the same name. IMS ID and the stall clock. All right, and the stall clock. The last 16 byte can be different. Think about it. When you do message switch like this 03 here may not run here. This 03, which is 81 SMB destination, which is a live, is equivalent to an 01 here. It's a live of a new transaction that can be executed in a different IMS. There's certain technique to tie them, but of course, this is just an introduction session. So it's pretty hard. It can be complicated. And if you want to see a complete picture of that, you have to merge the two SLDS together, right? To have a complete picture of your logical unit of work. But I just want to show you the elements here so that you know which record involved for you to determine the response time. And that's about all that you need. Otherwise, the other one, log sign on, sign off, MFS record, all of these things that we don't look at. Okay, so now let's look at the 59 fastpath. We don't have a lot of time, so I have to go quick. So 5901 is like input message. Same thing. 5903 is an output message. The same thing. 5950 is for database update. And then 5937 for sync point, 5936 is for message DQ. In the 5936 has all the response time of your transaction. Okay, and then and the all the timing for you in there. 5937 sync point give you the data of how many database call that you did. Okay, so and then and then for recovery 5912, 5612 for recovery. All right. So for your reference, these are that for the lock record, the important lock records for you to decide the response time of the transaction. Okay. Now, demo. I want to go quickly. So okay. So in here. All right. So for us to this is main view for IMS. Okay. I'm using this to help me to find the SLDS. Okay. So I'm going to go to the BRC menu. And I said, I want to look at the SLDS, prior lock record. Okay. So the data that I got is from, I just do a switch alt and then type a couple of transactions and then I switch all again so that I have a small log for you to see to do demo. So on that, I did it on the 5th, the 5th of April. So you have to run a DBRC job, a recon job to get the time in there. Okay. Oh, 22. Sorry. Okay. So I did it at this is a California time. It's just a very short time. As you can see here, it gives you the date and time of that, and then the first lock record and last lock record. So I'm just gonna hyperlink from here, and then it give me all that stats. I'm going to go to log analyzer, and then I didn't have this. Okay, so I'm gonna go to do that quickly. I'm gonna look at what I produce in here, and here you will see the logical unit of work. This is BMC log analyzer. Okay, so you can see that it's a EOW here, and this is what I took an example from. I'm gonna do a list that log. You can see right over here. Exactly from the presentation. I just cut and paste this. Okay, now somebody asked me about the MFS thing. So this when the VTime communication analyzer strip off based on device dependent module DDM and said okay, and he found the MFS and it stripped up all the MFS stuff. We're gonna dump the record to see what's in there. So you can see in here, it says IMS input message, as you can see right here, a +5 is an 01. You see that? That's a record 01. So this is the length of the lock record, LLZZ, 0229, 229 bytes, hex bytes, right? This is how you look at that. All right. Now, if you look in here, it says the message DRN, remember I told you about DRN, right? This relative record number, this is the number of that. So this right here, right, from the log record, right? So, so the DRN, when you look at over here, as a 04, you know that it's going to a short message queue. If it's an 08, you know that it's going to a long message queue. So, and then you can see here, the IMS here, you can see from here, which is I15Z is my IMS ID name, blank, blank, blank. This is the clock. DB4F is a clock, right? And this is a store clock, F007. All right. So this is, and then you can see the next one. Remember I told you 34 bytes. Okay. So the next one, this is plus 16 to the EOW. You see the same thing. It run locally. I15Z and F007. So the same store clock. It means that you run locally. Okay. So if you're running on another IMS, or if you create a new EOW when you write an 0381 SMB destination, you create a new processing EOW. That's how you tie them together. All right. Or you can use the DRN to tie in the same logical unit of work. But be careful, DRN is reusable. When you delete a DRN, it's available for the queue manager to reuse. So you may have the same DRN in the same EOW, logical unit of work, for multiple EOWs within the same logical unit of work, in the case that you do message switch or something like that, right? So be careful with that when you do log record matching. Okay, so I want to show the person asking me about MFS. You can see here. See the input message coming in to VTIME after VTIME communication log the record is IVTNO is the name of the transaction. Display Tran is my name, last name, and logs my first name. Okay, so you can see that it doesn't have any MFS thing in here. So MFS is outside of this. And you can see this is a node name, username, terminal. A lot of people, when I was system programmer, I always get called in and say, Loc, I want you to run a SAS program against log record to find out this person at what time they log on, he log on, and what time he log off, or which database he updates, which transaction he used. So that's how you find from those log record. Of course, sign on, sign off is, I think, log record 15, 16, and 70 something, right? So, so by looking at ILockRec, you will see all those log record, the log record that involve that you can look at to perform your task. Okay. So this is an 01. All right. And then let's look at the 35 NQ. Okay, so you have a same DRN. You can see that 1B8, same thing. So you know that they tie together. So this is a 35 NQ, the message, right? IVTNO, right? So let's look at the 08. So the 08 has, the crazy thing is it's hard to tie an 08 to the rest of the transaction, because you can see here the I15Z as something quick for us to look at doesn't have the store clock in it, but it uses a thing called recovery token to tie them instead of a store clock. 191600 19, you see IMS ID right here plus 191600. That's how you have the recovery token. But that recovery token also exists in other IMS log record for you to tie. Okay, so it's not on a one pathway for you to do. It's very complicated, but then I want to show you that so that you can see. So we tie by the you can see this thing is look like an EOW here, but it used the recovery token. Then if you look at the batch program, it also uses a recovery token. It doesn't use a SDCK, and it uses that recovery token to do restart, right? Right. So it's very important that you understand, that you know the difference there, right? So in here, it's a 56 also used, I think, is the recovery token to tie them, right? That's why it's shown there. Okay, so now we look at this O3 output message. This is interesting here. All right, you have a DRN. It write out on O3. You can see here 82. That's a CNT destination, which means that you're writing an output message to a terminal, to a destination. That's why we call CNT destination. It's very important. When you see an 0381 right here, you know that's the beginning of a new transaction. It's equivalent to an 01. All right. So in here, you can see that it's writing out. You can see all the data by looking at the DSEC mapping. You will see that. You can see here. Yeah. The entry was display. This is the result. And then this is a display. Display, Tran, and then Tran, log. I think you guys have IVT and O2 from IBM provided you, so you know what is the form going to look like. So this is prior to MFS, right? In those log record, you can see that it says MFS is being used, so IMS know how to put back the MFS and display back to you. But to the transaction, O3 doesn't know MFS, right? So it just give you in this format, and this format will be translated to MFS to display in the nicer form, right? So that's how you see it. Right? Another point that I want to make is that for those who have access to these log record, need to be authorized, right? Because you can see from those log record I'm showing you here, you can see, let's say it's a bank trying to update, an account with $1 million. You see all that. So let's be careful with the person access the SLDS can put the picture together. Why? Because if IMS fail, it can bring back to the way it was. It can use all these log record to reconstruct what happened. So it's important. So NQ and all that, you saw that. And you can see here is a 3301 here. I want to show you the delete of the message. See, so this DRN right in here, you see 1B8, remember the 01 that with a DRN 1B8? He deleted the message out of it. But after that, after this 3301 execute, right? After it locked this gun, that address 04 1B8, relative record number 1B8 out of the short queue, will be able to reuse, even with the same EOW. Okay, so be careful with that, so you don't match the wrong guy. Okay, so you can see in here, this 03 got a different DRN. Let's go back to this, the output message. This DRN is 1B9. You see that? 1B9. So in here, if you look at this 3301, that's a deletion of that guy, 1B9. You see? So you have to match the right guy. Okay, I want to bring up a situation here. You do an 03, write a message to a terminal, CNT destination. But that doesn't mean, in this case, that, yeah, I have my terminal ready. What if your terminal is off? It's not connected to IMS anymore. This message will stay in the queue, right? So output message won't be delivered. It could be an hour later. It could be the next day. The person sign off, and then sign on. So it might take that long to deliver the message. So when you decide what to do with that, you have to take care of this situation also, right? Just this thing is online, it's fast, it's quick. You have the message, type a transaction name in, and the message coming back right away. So you don't have that, but you may have a message staying in the queue, right, without delivering. So you don't have this 31 here. You don't have this 36 DQ of that message. You don't have this 33 either. So let's be careful with that. Okay, now we look at message switch. All right, so you can see here, same thing. It came into the system, away, blah, 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 up to here, and it's you an 03 here. Okay, let's look at this guy. See, it's an SMB destination. It's a message switch from this transaction to this transaction to the same guy. So if you look at over here, 03, remember when I showed you the CNT was an 82, this is an 81. That's equivalent to an 01 here. That's why the macro represent 01 and 03 is the same macro. Same macro, same DSEC. All right. So don't look for L03. You won't find it. In the ILockRec, you have to look at L01 that cover L03 also. Yeah, when I just started learning about IMS lock record, I was really confused. I didn't understand that, and it took me a long time to find that out. Okay, so okay, now so you can see that that transaction do a message switch. So what does it do? It message switch to, see, that transaction R131 switch message, right? So as you can see here, it's going through exactly the same thing that you saw there, except that near the end, okay, that's the end. This 03 is writing out an output message, same as the output message. This guy doesn't say exactly, but it should have said it's a SMB destination. But it did before when you do a dump. So let's look at this 03 here. The application message switched 2 times, dump. Okay, you see that? An 0382. See that? 0382. So it means that I'm writing a reply to the terminal. And which terminal is that? It's here. TCP D062 node name with an L term and a user ID. Okay, so let's look at that. What did we write? Okay, response. So we wrote out this message, delivered to the terminal. Okay, so it deliver. When it delivered the terminal, it going to the 36 to DQ it. Okay, to DQ the message. I don't know this one. It must have the DRN. Yeah. Okay, let's see which one is the DRN. Doesn't matter, but I just want to, yeah, here. 0401B9. He DQ this DRN. So you can use a combination of DRN and UW to match them, or the recovery token depends on the lock record type, okay? And then this guy deletes it, 3301 deletes it. All right, so I'm available for questions, more questions.
Okay, I've got a question. It came up a couple of minutes ago, but the question is there user data encryption for log records?
Yes, I heard that there is. And for example, I know customer, when they send us SLDS for diagnosis, they run a program to wipe out sensitive fields like output message, like a database undo, redo, things like that. But encryption of log record, I'm not sure about that. The whole log record, you mean?
Sure, that's all was in the question box.
Yeah. People worry about security. I guess so. I guess that encryption is a hardware feature, isn't it? That you put that data set on that is going to encrypt it.
Yeah, no, Karen's just come back to me. She's saying, no, just the customer sensitive stuff. That's what she's asking about, whether that's encrypted.
Yeah, okay. Yeah, so they do have program to do that. Yeah. Yeah, for example, on the O3, for example, output message. Let's look at this O3. You don't want people to see down here. You don't want to say, okay, your account just we just updated your account with $1 million. You know, you don't want to see that message, so they zero out the field by looking at the record. If you look at the record here, there's an offset, right, to everything, to the data. So this length of this this MSC is 25D. So they know the location of O3 that, okay, I'm going to blank out that area. Okay, that you guys shouldn't look at it in terms when you investigate the log record. Okay? So because I'm using, I'm using a BMC log analyzer product to give me this. But a lot of time, and you have to use ERA 10 and ERA 30 to format things equivalent like this. It's not gonna be equivalent, but for example, a lot of time that we want to know what's going on with the transaction, we look at the FA. Of course, our FA is much more detailed of what's going on. We look at this, we can see all the trace where we went through and where we got the data, all the timing, waiting, and all that. Like we even collect CPU per event. And then waiting time per event. For example, you wait for a latch. We tell you how much time you spend waiting for latch, how much time you wait for iWait, how much time that you wait for some of that you see in the 56FA. Okay, 56FA is almost equivalent to the 07 record, but it cut the data by transaction. The 07 has a combined data for all transactions being executed in one iteration between 08 and 07. So if you know that, then it's easier for you to navigate through IMS log record. I hope that I make sense. You know, but when I was a newcomer to system programming, it took me a long time to understand all of little things here, and I hope that I can pass to you as a beginning. Log record are very. Every time I fix a problem or I look at this, I'm learning something new. So I'm by no means an expert in this area, even though I work with this for a long time. You know, with landmark system, TMON, and and here, and I even wrote SAS program to to analyze the SLDS when I was in the production environment. You know, so I hope that I help you a little bit here to accelerate your study, your investigation.
Yeah, no, that was
Any other
very good.
questions?
You seem amazingly knowledgeable. So there's so much
Yeah,
information
like
there. Thank you.
you see, FastPath is a different animal. Let's look at FastPath. Let's look at FastPath. Sorry, it's a list. Wrong keyword. See, these are the record 590103, and they are very different. The way that they process the name by the name FastPath. When it write log record, the ILog, the EDECB using it packed them together. So 590103, 5950, 37, they pack them together as one piece and then put in the buffer. Yeah, if you want to look at in the buffer, you parse it out. You know, you look at that and say, oh my God, they pack it out. The reason they want to do that because they don't want to do an ILock, because ILock create a lot of interrupts in the in IMS. For example, you write one, you have to write, let's say that 01 is by itself. You write an input message 01, it by itself, right? So you have to go into the watts. You write that log record to the watts and say, are you okay? The watts say, okay, I already wrote it. Okay, and then it moved the data to the buffer, and then the log buffer until it's full, then you write it out. So a lot of wait time in there in the ILock process. So I fast said, no, I don't want to do that. I want to be one shot for everything. So it's very interesting. It's so much stuff that. But then if you look at the 5936 here, I hope that I have one for you to see. Yeah, this is a lock DQ right here. So you can see that. You guys see my screen, right?
Yes.
This is a DBF LGR DQ. See, output message DQ lock record. Okay, you can see that a lot of statistics in here. See, output message DQ lock record. Okay, and all the time of input message on the EMH. This EMH transaction, and time of output message on EMH queue. You can see that a lot of timing in here for you to find out. You can see that here, DQ time. Yeah, term output time. Okay, in microsecond. So you have all the timing here for you, where it deliver the message to the fast path terminal. So so let's say that in here you can see these guy, right? IM is for probably input message. Let's look at that. Select. Right. This is what does it say? Input message lock record 5901. Okay, 5901. Blah 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 blah. Input. If you want to find input response time, come here and look at it. Right. So yeah. So if you switch, let me switch that to here. Oh no. Here. Yeah. So you can see that the set that you're looking at, and then if you this is an older version of BMC Lock Analyzer with the new 1.7, I think, version 1.7. When we do this, we can map with the DSET. It tells you what the field is. For example, let's say you dump like this. You can map all the values here with the field. So it's easier for you to see, oh, this value means that. In here, I have to kind of decode it. So that's that. Any other question for me?
Nothing in the chat at the moment. Because of the time, perhaps we can move on. And if anyone does have any questions, they can email them to me. My email address will be on screen in a minute, and I'll pass them on to Loc, and he'll get back to you with an answer, I'm sure.
Okay. So, sorry about that. I was late.
Yeah, no, not a problem. I mean, the technology always does strange things every now and again. We're all familiar with that. Right. Let me say thank you very much, Loc. That was full of great information, and yes, people are putting in the chat. Thank you. It was good. Because we're a virtual user group, can you assume that we're giving you a virtual round of applause now? And let me just take control back. I'll become presenter and I'll share my screen, and I'll just quickly run through the last couple of little bits. There we are. So, in terms of news, you remember Dusty Rivers, who was speaking last time, was saying that they had a new announcement that came out a couple of days ago. So we find that Adaptogent has this intelligent caching engine, which is great for people who are using IMS APIs. And as for articles and blogs, there have been quite a few. We've got this IMS and JVM streaming via Amigamon data provider now available. Is your IMS restart taking too long? Could it be hung? And we got go ahead, be picky, import only the DVDs and PSBs that you want. We got IMS 15 managed ACB enhancement option, no check to import def and source catalog. Good news, 31-bit COBOL can now talk to 64-bit Java in IMS. And go ahead, store more data in IBM IMS DDB databases, up to 40 terabytes of data. And what happens when you pair ZOS Connect with IMS? Okay, yeah, so there's quite a few of those. There's links to all those on our website. So, coming soon, then we've got Hayley Fung, who spoke just before Christmas. She's coming back in June to tell us more about Ansible. And then on the 9th of August, we've got James Martin from Rocket Software. We haven't finalized the topic for that, but James has spoken before and he's always very interesting. Just a reminder that you can keep up to date with what's happening in the world of IMS and on the Virtual IMS User Group website by following us on Facebook and Twitter, and by joining the Virtual IMS group on LinkedIn. Again, the URLs are on the home page. You don't need to write down the ones that are on screen now. If you tweet, then the hashtag to use is Virtual IMS, and I've got the YouTube icon there, just to say that we've got a YouTube channel. If we get 100 people subscribing to it, we can get a sensible name instead of it's currently called channel/UCP in caps P7. You get the idea. So if you can like that, and there's a link to it, obviously, on our web page. Okay, that's all for this meeting of the Virtual IMS User Group. Can I thank you all for attending? Thanks to Rocket Software and BMC Software for sponsoring our user group. And I particularly want to thank Loc Tran for today's excellent presentation. So that's it. Thank you all very much for joining the meeting. And I look forward to seeing you on the 14th of June. So that's it.
Thank you.
Thank you all and goodbye.
Bye.